This is chapter 5, problem number 18. Determine the component of reaction at the support A and B on the rod. So we are looking for what's going on here. Okay, if you pay attention over here, what it is a rod like this, but it's all connected with balls. That means there's no friction on this side. There's no friction over here. However, you will find a force, a normal force coming either on this side or on this side. But there is no force in the y direction because it's freely moving. Okay, we are not talking about this point over here. We're just talking about the ball. All right, based on this, because we know that there is no support on this side, okay, so the y, it will be equal to 0. So whatever the pressure coming down, it should be the pressure based on this point, okay? If this is a P, then this must be P over here. However, if you look at a system like this, okay, if you have another support over here, another support over here, and you have a force P pushing it down, in this case, because there's a support over here, okay, and if the length is equal on both sides, that means if this is a P over here, you feel P divided by 2. On the other side, you feel P divided by 2. This way, you will not feel it because there's no friction, nothing holding it. All right, so let's get back to the problem. Okay, so if the sum of the force in the y direction is equal to 0, okay, sum of the force in the y direction equal to 0, that means if P over here, it must be P going up, okay, and in the y direction is 0, okay. So in the x direction, this is not giving any x, and therefore this must be 0. Let's pay attention on the sum of the moment and see what happened. Okay, we are going to take, for example, this one as my pivot over here. Let's see, the moment going clockwise is this P. Okay, so that would be equal to, this is a P times L divided by 2. Okay, and this one counterclockwise, oh, this is minus, this is a positive, counterclockwise, P times, you add this up, is equal to L divided by 2 and then multiply by 2. Okay, in other words, P times L. You may think, how come these two, it will not add up to be 0? So what is going on over here? Something is not right. If you think like that, you're right, because so far what we have exposed to is a system like this. For example, if it's not this type of connection, if this one is holding it, something like this, which is allowing it to move freely up and down in this direction, making an arc. See, this one, you cannot move it in this direction. You can't, okay, because this thing is straight. This one, you can move it. In this case, it's very different. Look at the different connections. If you have P over here pushing it down, what you find over here, it will be half of a P pushing it up in order to make the moment equal to 0. In this case, over here, in fact, it's going to feel a moment. And sometimes you see a problem giving like this. That's exactly what it is. So in this system, it's going to feel a moment. That means if this point is weak, it's going to break over here. So there is a moment at point A that is making it balance. So the sum of the moment, overall moment, if this is my pivot, sum of the moment will be equal to 0. Okay. Yes, I know it's complicated for the first time. It's tough to understand. But in this case, if it does not have the pivot like this, if this thing cannot rotate, then yes, you can feel a moment over there. Let me give you another example, which you may see something like this. For example, if you mount something on the ground like this, and you have a beam coming out, okay? So you are gonna feel a moment over here because this one is not a hinge type. You mount it over here. When it's a hinge type, yes, the moment will be 0 because this thing is freely to move, so you don't feel a moment over here. But you will feel a moment over here. So you are gonna see something like this, and this joint over here. The lucky number for this one is 6, number 6.